One.
Ladies and gentlemen, good afternoon, good morning. I'm Donatella Ponziani, ESA Downstream Gateway Officer, and I have the great pleasure to welcome you all from around the world to the second episode of the series of webinar Space for Twin City, dedicated today to air quality. Without any further delay, I would like to hand over to the moderator for this session, my colleague, Robert Meissner, who is today coordinator of the FEE Experience and the Earth Observation Outreach in ESA. Robert has studied geoscience at the University of Munich. He holds a PhD from the Free University of Berlin. Before joining ESA in 2008, he worked for the University College in London and in DLR. He was also seconded in JPL in Pasadena. He has 25 years experience in Earth observation from space, and he contributed to several space missions. He will introduce the session and our distinguished speaker. Robert, the floor is yours. Thank you.
Thank you, Donatella. Thank you very much. A warm welcome also from my side to our viewers, but also to our guests from all around the world. I welcome you to this webinar on air quality and space. This is a wide topic. We're going to see a lot of different things and a lot of different areas which we need to and should discuss. I do not think we can cover all this in this webinar today, but we will do our best to give you a good overview, and I'm sure our guests will greatly contribute to that. We have some very interesting interventions, and please allow me to give you a short introduction to our guests. The first person I'd like to address, will also be our sequence of presentations. I may introduce to you Romain Bastiste. He's the deputy of the Air Quality Division at the Urban Ecology Agency in the city of Paris, so responsible for this part. And he's an urban engineer from training from the Paris School of Urban Engineering, so a true person who knows what he's talking about. I may also welcome at a very early hour at where you are, John Olm, the Deputy Mayor for Budget and Innovation of the City of Los Angeles. John is looking into issues ranging from homelessness to digital equity, technology, innovation, data and analytics, fiscal transparency, public-private partnerships. So you see a wide range of responsibilities. And she's also a former consultant with the World Bank and a former chief knowledge architect at NASA. So to speak, a little bit of a colleague from another space agency or former colleague. I would also like to introduce to you Massimiliano Ferrante. He's a dear colleague, but he's also an electronic engineer, and he's responsible in ESA's Earth Observation Center in Frascati in Italy for the lab services. And he's been working there for more than 10 years for managing the AF antenna there and also the lab service in Frascati. Last not least, I would also like to welcome a dear colleague, Roberta Mugilesi, another colleague who is working in business application management in the Downstream Business Applications Department of what we call the TIA Directorate. TIA stands for Telecommunications and Integrated Applications at ESA. She's been involved as a project manager in the development of more than 40 services dealing with all kinds of applications, transport, maritime, fishing, and infrastructure monitoring. So welcome from my side to everybody again. Also, if you may have joined a bit later, we are in the webinar on air quality, looking at smart cities. And I will now take the liberty to act in my double role as moderator and presenter. And I will give you a little bit of an introduction of what the satellites ESA and other space agencies have in orbit can see from space related to air quality. I'd like to give you some examples. And I think we should jump right into the first slide, where we can get an overview. And what you see here are all the satellites that ESA has developed or is currently developing, which are in the making. You can see we're at 2020 now, and we have currently 15 satellites in operation. We're going to add a 16th one on Saturday, Sentinel-6, which will be looking at sea level rise, but this is not our topic today. We have 3 lines of satellites basically in ESA. One is for the scientific community, where we are testing new technologies, where we are taking the latest in technology that's doable today. Aeolus is one of our satellites, which is looking into wind, which is using a very, very advanced technology for doing this. We have what we call the Copernicus satellites, which are built and designed by ESA for the European Commission. This is the biggest Earth observation program in the world, and it's a fully operational program. Looking at Earth, I'll get to this in a second. And last not least, we have the meteorology missions, which we built and developed together with our partner EUMETSAT, who is providing satellite data for meteorology, so for weather forecasts. And when we say weather forecasts, of course, it's not so much about going to the beach, but it's more about if you get into an airplane or a ship, safe travels. It's interesting for agricultural applications and all kinds of other things. And of course, meteorology also deals with these gases that make our life difficult in the cities and which have a negative impact on air quality. Can I have the next slide, please? I would like to go directly into what our satellites see, and I've just mentioned the Copernicus satellites. Sentinel-5P, this is one of these Copernicus satellites, and it's a very dedicated mission only looking at our atmosphere, mainly with a focus on air quality. And what you see here is one of the many maps that Sentinel-5P can produce. It's the concentration of nitrogen dioxide in the atmosphere. And what you clearly see in red means high values of NO2, so bad air quality, yellow in the middle, and in the bluish it goes relatively low. And you can see on the right side, China as a big red blob over the whole mainland of China. We have very high NO2 concentrations traditionally. If you look a little closer to Europe, you can see in the further east, the red dot, this is Moscow. And generally, we have also very high air pollution values or NO2 values in Europe. We can take a closer look at that. Can I have the next one, please? This is what you see here is a map of Europe during the COVID lockdowns. So all of Spain, France, and Italy was more or less under lockdown. And this is the drop in NO2 concentrations. Paris dropped by 50%, Rome also, every big city in Europe basically lost NO2 concentrations of up to 50%, which is quite a lot. Can I have the next one, please? Because under normal conditions, it looks much more polluted and you have much higher values. So this was really a drastic difference. My next example takes us to California. And can I have the next one, please? And what we see here on the left, the brownish grayish mass, this is all smoke from the fires we had in California in September and October of this year. On the right side, we have a similar situation some years ago. These wildfires are becoming more and they're becoming more intense due to many years of drought conditions in California in the past years, and due also supposedly to a changing climate. Can I have the next one, please? But the smoke images you can see, the smoke you can see with your eyes. But what we're looking at, and this is what we're looking at now here, is the carbon monoxide concentration or the NO2 concentration. These are all trace gases we cannot see with our eyes, and we need special technology, which Sentinel-5P has on board, to do exactly this, to look at trace gases which are invisible to our eyes. And what you see here are the very high carbon monoxide concentrations during the big wildfires we had this year in California. Last not least, I have a small example what we're trying to do, because we have one issue. Can I have the next slide, please? One more example on NO2, same thing, but here you see the lockdown in India. And what you see is that the big cities like Mumbai and Delhi, they went almost to in very, very low values, but the power plants, which create electricity from coal, they remained relatively high because they had to continue to produce the electricity. And now my last example, the next slide, please. We have one problem with a lot of satellite data. We cannot, in the moment, measure trace gases in very high resolution. So our pixels on the ground are relatively large, especially when it comes down to city limits. And the next slide, please. But we're using new interpolation technology where geostatistical data is used and other information, background information from geographic information systems, to increase through modeling and also through interpolation, the quality of the data. On the right side, you see a more realistic scenario where the very high values along the main roads, for example, become clearer and better visible. But I'm pretty sure that we will hear something on these issues and the problems related to that from our speakers. And this brings me to the end of my little introduction on the topic, because I had a feeling we need to make the link between the space and air quality as we would like to discuss this topic today. Now, I would like to hand over to Romain Baptiste from Paris and hope he will provide us with an overview on air quality monitoring in the municipality of Paris. Romain, please.
Hello, everyone. So we'll talk to you about the air quality monitoring in the city of Paris. In the first time, can I have the next one, please? In the first time, I will talk about Air Paris, the regional association dedicated to air quality monitoring. In the second time, about Parisian projects, about citizens and measures. And on the third time, the assessment of microsensor network deployment in Paris, the Bloomberg project. Alors, first time, the Air Paris. The next one, please. Air Paris, the regional association dedicated to air quality monitoring. So, next one, please. Air Paris is a member of the ASQUA network. The ASQUA for Official Agency for Air Quality Monitoring were created in the 1970s. There are 19 agencies in France, in metropolitan regions and overseas territories. Air Paris was created in 1979 and is dedicated to the region Île-de-France, which englobes Paris. About the measurement network of Air Paris, there is about 71 stations, among them 58 automatic along the traffic axis. 13 stations are put in Paris intramuros. The radius from Paris of measurement is of 100 kilometers, which represents about 11 million inhabitants. There is about 65 employees in Air Paris agency, and in the early years there were only 5. There are also 137 sensing equipments for punctual campaigns. Can I have the next one, please? The different goals of Air Paris are measurement of air quality with measuring stations, establishing the emissions inventory of air pollutant emissions in order to make modelizations and studies about air pollution. As we can see, a model of modelization on the right. And you can see on the down of the slide some mobile equipment like cars, bikes, which are used for punctual and campaign measurement, like some campaigns about the ring circle of Paris. The next one, please. The link between Air Paris and Paris is seeable on the website of Paris. In 2019, we put a page dedicated to air quality. On the front page of paris.fr, you have a little widget which is telling the air quality of the day and of the hour. And when you click on this website, you're directed to the page of air quality, which dispose a map which is updated every hour, showing nitrogen dioxide, ozone, PM10, and PM2.5. Can I have the next one, please? And in Paris, we also have a service which is called Parisian Service for Environmental Health, which has certificated measuring stations. Then you can do diagnostic before and after urban plannings. You can also do outdoor air quality campaigns, like soon in 2021, we will do a study about emissions of air pollutant of boats that goes on the Seine. So they will do their measurement on the banks of the Seine. They can also do indoor air quality measurement, like in school, for example. And every year, surveillance about the pollens in the air in order to prevent the allergies. Can I have the next one, please? Second time, citizens and measures some of Parisian projects. Next one, please. So in 2017, a project was voted by citizens in Paris in the budget participative. It is a part of the budget of the city. Each year is voted by citizens. Some citizens put some ideas, and if other citizens agree with these propositions, they vote for. And the ideas and projects which has the most of votes are kept for being done. So this project was named Respirons mieux dans le 20e, which is for Breathe Better in the 20th district. It was about lending about 70 microsensors to Parisians of the 20th district. And Air Paris put 10 micro stations in the district. We can see on the map their places, their sites. These micro stations were about to have reference stations to check the data measured by the sensor in order to recalibrate and to check every in particular data. The citizens were followed by the city of Paris for the organization, the land of sensors, the meeting to bring health sensibilization information, by Air Paris too, to process the data, and by researchers who were working about the theme of citizens measurements and how to use it and its capability. And scientists were there too to check the habits of Parisians at the start of the experimentations and at the end to check the difference and how people evolve in their minds about air quality problems. This project led to another bigger voted in 2009 by 25,000 Parisians called Fight Against All Pollution. And this project will be led in 2021. It is in process. It will concern all Paris and not only air pollution but also noise pollution. Can I have the next one, please? So now the assessment of microsensor network deployment in Paris, the Bloomberg project. This project was a collaboration with Bloomberg Philanthropies, which put the funds, Clarity, which was the technical part, with about not about, it was 138 solar sensors deployed, and air tariff. We can see on the upright peak the Paris mayor, Mr. Bloomberg, some people of Clarity, and on the far right, the director general of air tariff. So there were 44 schools equipped. On the playground and on the streets, you can see the sites on the map on the down right. The pollutant measured were NO2 and PM2.5. To assess this data measured by this sensor, some NO2 passive tubs were placed by Air Paris and the city of Paris, a double check in every school to check the data measured by the sensor put in the school. So now these measures have been done. They are checked, and soon the report will be published, about in the end of the year. Thank you for it.
Thank you very much, Romain, for this interesting presentation. Next, excuse me. Next on our speaker list is Sean Holm from the Los Angeles municipality, and she will let us see how the city of Los Angeles is dealing with air quality in their city. Sean, please. Sean, can you hear us? Sean? I see the slide. I cannot hear anything. Is Sean still there? Do we know? Her microphone is muted. I can see that. Okay, here we come.
My computer had a problem.
Okay.
So
but now we can hear you. Great. Thank you.
Perfect. Thank you so much. Thanks so much for inviting me here. It's an honor to speak with all of you about the work that we're doing in Los Angeles. And the project, I'm going to talk about a specific project that we're doing called Predicting What We Breathe. Next slide. So in Los Angeles, we have the dubious honor of having some of the worst air quality in the United States. Part of that is our geography. We're surrounded by a ring of mountains, and so the offshore breezes tend to keep the pollution in the area. But we're just also a very large city. There are 4 million people in the city of Los Angeles. There are 13 million people in the metropolitan area. It's a very active city as well. We're the 13th largest economy in the world, just our metropolitan area. And there's a huge manufacturing hub as well as having some of the worst traffic in the world. So all these things combine to make air quality an ongoing challenge in Los Angeles. Particularly right now, we're concerned about the health effects of air quality as it relates to COVID. We know that people who have asthma and other pulmonary diseases tend to have a higher incidence of severity of COVID, a higher incidence of death. And then we know and suspect that we're starting to see long-term effects as well that relate between people's issues with asthma and air quality and COVID. So we're really focused on this right now. We recently won a large NASA grant to look at the way in which we could use machine learning to better understand how we could combine data from space and data from the ground sensors. So this picture here just shows you what the ability for a city to regulate air quality can do. In this case, an unregulated 1960s version when I grew up in Los Angeles, we would have smog days like other people would have snow days where it was too smoggy, too unhealthy to be able to go to school, and so we would have to stay home. To a more recent time, now we get a lot of cleaner air, but we still have a lot of challenges. The next slide. So we do have a lot of air quality data coming in. We have data from space. We have data from our ground sensors. We even have citizen science type of data where people are putting together Purple Air and SafeCast and other small sensors that they can just buy and put up in their yard to monitor their air quality and then choose to share that data publicly. But the problem is that the approaches we have today lack a lot of city-to-city collaboration. So the things we can do to change air quality are regulations on manufacturing, traffic, gasoline mixes and blends. There's a lot that a local government can do, but we need to collaborate better. There is the C40, which Mayor of Los Angeles, Mayor Eric Garcetti, chairs, and we are doing some active work there. But partly we wanted to make it very actionable for cities to use satellite data in a way that manifestly improves their air quality. And the other thing is when we think just about satellite data, it's 9 to 30 kilometer swaths looking over a city, which is hard for us to sort of understand the local implementations and local issues. And then we also look at local ground data sensors, and those are maybe a half a block wide, or measure the air quality just in a backyard, essentially. And so we wanted to be able to combine these two and put together a better plan. Next slide. So what we're doing with the grant is we're identifying and mapping all of the regional air quality sensors. So there, as Paris has an organization that works regionally across this country, we also have in Southern California a regional air quality group called the Air Quality Management District. They have some large heavy-duty sensors. There are smaller cities around the area that have some sensors. And as a city, we ourselves have sensors on some of our streetlights, on some of our trash trucks, at our landfills, by the Port of Los Angeles, and by the Airport of Los Angeles. So we're putting together the map that shows all of these sensors and normalizes and gathers the data from all of them in a way that can then be shared out to other people. We're also looking at the issues around environmental justice. So as we're putting together this map, we're realizing that there are some large gaps in the sensor network. And when we start to put a socioeconomic lens on that, we realize that those are often in poorer communities. So historically, over time, decisions have been made for whatever reasons that have left communities behind. And so we're looking to fill in some of those gaps as well. And then we're working with our public library, which is a department of the City of Los Angeles, to be able to distribute citizen science small sensors out to folks so they can actually go to the library and they can check out a library book, or they can check out a laptop or a Wi-Fi hotspot too. They can also check out a Purple Air sensor to be able to take home and understand, gather data, be able to do a class assignment or an experiment. Or if they're in an environmental justice area, be able to just keep that sensor and be able to help add to the measurements that we're getting. Next slide. So the way the experiment is that we're working on is really trying to predict. So we're actually looking at some of that very data that we heard about earlier, looking at NO2 and also particulate matter. And what we're trying to do is take the satellite data and the ground data sensors, combine the data sources for both of those, normalize them, and be able to fill in the gaps through a mathematical model. We're using both a neural network model and a long-term convolutional network model. This lets us look at both the timing and the periodicity of the data, as well as the data over a specific geography. So here you can see some of our very early work in trying to be able to predict in our machine learning training set the air quality that we're going to have in 2 days, in 4 days, in 6 days. And you can see that the maps from one side to the other, which are the predictive model versus the actual data that we are trying to predict to, are pretty similar. And so we're finding that the combination of these two different kinds of models using machine learning against these large, complex, dispersed data sets is really helpful. Next slide. And so for NASA, the main point is to really look at applying this machine learning to these large disparate data sets. Our first satellite data set was actually a European Space Agency data set from Sentinel, so I'm really glad that you're adding to the constellation this week. We find that data has been really helpful, and the MAIAC data as well, and soon the Maya data as NASA launches that next satellite. And the idea was also to learn how to integrate to local data. The other piece we're trying to do is make sure that we work with cities all over the world. If you are working with air quality in a city or a county, we would love to, our region, we would love to work with you. We have an air quality sister city network that we're setting up, and we'll be providing support and training on how to use machine learning and where to get access to the data for your city. Next slide. And we're just seeing so many benefits to the city. And so I don't want to go too far over my time, but I just want to say that in addition to deploying the sensor network, which is sometimes difficult for cities, we're really also working with our work on the C40 network and the UN Sustainable Development Goals, which has been adopted by the City of LA as part of the way in which we manage and measure. And we output this data in formats that are helpful to different healthcare providers and folks working with the Southern California Asthma Association so that we can help to have them improve their clients' health benefits. I think the last slide is just a list of our partners. If you're interested in partnering with us, we'd love to partner with you wherever you are in the world and whatever your air quality issues are. Just reach out to us at airquality@lacity.org.
Thank you very much, John, for this interesting. I find it very interesting to see what the cities are doing and what approach they take. And I'm pretty sure that our next speaker, Massimiliano Ferrante, he can give you some ideas for future projects. I've already seen that you're involving schools, and Massimiliano is going to tell us about the educational role for data towards the air quality monitoring services that we have at hand today. Massimiliano, please.
Thank you, Robert. This presentation describes the AQP project. The acronym AQP stands for Air Quality Platform. The next slide shows the first AQP version, the educational version, that is an assembly kit, hardware and software, capable to sense some local ambient parameters and send the data to a ESA central server. It was designed and built internally in ESA at the ESA Esing laboratory for the Living Planet Symposium 2019 school laboratory for educational purpose. This AQP is composed of a very cheap sensor. We were all procured on Amazon, and then the material cost of this kit was below 200 euro per unit. The software that runs on this platform, Raspberry Pi and Arduino, is open source and is written in Python and in C. We can consider open even the hardware because it is possible to add other electronic components and sensor on the breadboard that is on the top of this AQP. Using the chip sensor, this platform is able to measure 11 parameters as temperature, humidity, PM10, PM2.5, CO2, CO, NH3, ammonia, NO2, CH4, methane, atmospheric pressure, and position using the GPS. The next slide shows a block diagram of the AQP and the involved topics in this activity. The AQP system is composed of three main subsystems: website, platforms, and satellite data. These subsystems communicate each other using internet. Each platform measures local air parameters in situ and sends them periodically to a web server where the data are georeferenced on a world map. Then user can access the website from internet and overlay the latest Sentinel-5P data on the map. Each AQP sends about every second its measurement to the web server, where the data are stored in the DB and then is visualized the map on the real time. The next slide shows all micro version of the AQP. The first is the educational version that was described in the second slide. The next is the exhibition version that is used for demo and for exhibition in the conference. The next one is the calibration sensor. The scope of this platform is to verify the functionality of the chip sensors, define the conversion curve from physical value and electrical values, and then correct the values provided by the sensor for comparison with a professional instruments. Then there is Lotus, that is a special demo unit. This is very complex AQP that we'll describe later. Then there is a backpack that is the first wearable AQP. where an EQP, battery pack, a 4G connection to internet, and then a small solar panel are integrated in the backpack. Then there are two EQP units ongoing. The first one is EQP Automotive. It was designed to resist to a remarkable vibration and electromagnetic noise. The last one is the EQP Mobile. This platform is composed of a rover and an EQP with professional instrument. In this way, this platform can reach the other sensor, and then, measuring the same ambient condition, it will be possible to align, correct the values of the sensor. Moreover, this platform can measure the quality of the air in different places and in different time. The next slide shows 4 EQP Internet of Things. We can see their picture and the picture of the ESIN EO laboratory to design and build them. The architecture of this device is very simple. In fact, they are composed of one Internet of Things sensor, microprocessor, the interface, electronic interface, and then the chosen sensor. The first measures temperature and humidity, and it is installed in a garden with solar panel and battery. Then there is the light that has a standard power network plug and the CO2 as a sensor. With this device, it is possible to turn on and off the light of LED and measure CO2 remotely. Then there is a micro USB Internet of Things sensor CO2. This one can be connected as a normal mobile phone. And then the last one is this one. We have CO, NH3 and NO2 installed in a small bottle with a USB connector. All these sensors transmit data to ESA web server or to a macro EQP. This kind of the device are very important in order to increase the number of the measurement points and so the monitored area. The next slide shows the current EQP coverage. It is possible to see how about 40 EQP platforms are located in Europe. 20 units were deployed during the ESA LP19 in the surrounding of Milan, mainly in the secondary school and the University Politecnico di Milano, 5 units in the Politecnico. Then there is also the involvement of ESERO, European Space Educational Resource Official Nation Desk, and now 6 units are currently under evaluation. In this map, once a specific EQP is selected, the current and the historical measurement of the EQP sensor are shown in the website. In the map, the user also has the possibility to add the latest Sentinel-5P acquisition. In this way, it is possible also to enable a direct comparison on the data acquired by satellite and the sensor acquired by EQP. The next slide shows how each macro EQP is able to implement data analysis. Using Python and importing math Python libraries, it is possible to apply any kind of mathematical function to the data, in real time or in post-processing. The same happens for the machine learning algorithms. Each macro EQP implements autoregressive model and machine learning algorithms to estimate the eventual anomalies in the sensor. It is important to highlight that the chip sensor cannot be used for scientific measurement, but we are investigating and implementing some machine learning algorithms to decrease the measurement uncertainty and the measurement error due to the use of chip sensors. The next slide shows Lotus, that is a special multidisciplinary platform. It is a globe opening as a lotus flower. It has 6 petals, and for each petals there is a sensor for measuring the quality of the air. Then there is a monitor to visualize directly the value of the sensor and the Sentinel-5P data. There are also 12 servos that provide 12 degrees of freedom to move the petals. And this platform implements many other functionalities. The next slide The next slide shows an experiment where a child was walking along a street wearing a backpack. We took a video of this walk, and then in the same time, using the AQP backpack, we were able to visualize the position of the backpack in the map, so means the position of the child, and then the value of the sensor for measuring the quality of the air. It was really easy to discover that there was a track to make that CO2 peak highlighted in the graph when it passed close to the backpack. At the end, we can see a possible application for the micro AQP lamps. They can be used in the street. They can be used street light both for light and for measuring the quality of the air. It is possible imagine how the measurement points and the dimension of the monitor area can be increased using this kind of sensor. The last slide shows the contact point of the AQP project. Thank you for your attention.
Thank you, Massimiliano, for this. Could be interesting to combine this, of course, with different sensors already existing and satellite data. I'm now looking forward to the presentation of Roberta Mugilesi, who will give us an introduction how space technologies are improving the monitoring and modeling of the air quality data. So another step on what space can contribute. Thank you. Roberta, please.
Thank you, Robert, for the introduction. Thank you for having me invited to participate to this event. So today I will start giving an overview of the kind of projects that we are supporting our team, which is the ESA Space Solution, in the area of smart city, in particular addressing the air quality, so the topic of today. So moving to the second slide. So as an overview of what a space solution is, so we are a team in ESA, which is primarily looking in supporting company based in ESA member states to develop, to implement sustainable application and services that combine space technology with terrestrial and other technologies to address opportunity which arise in any vertical market. So far we have invested more than 250 million euro about in launching innovative services with more than 1,500 companies. Now moving to the next slide. So the activity we are involved in basically integrate and leverage space and no space technology, combined also with other technological breakthrough like 5G, augmented virtual reality, artificial intelligence, to create business innovation in a large variety of sectors. So when we are talking about the space asset, this is basically in our understanding any possible combination of space technology. So from Earth observation to satellite navigation, satellite communication, and also possibly human space flight, addressing opportunity that may arise in one of these vertical sectors, but in particular addressing what are the customer user needs and requirements. And we are doing this often with partners that want to explore how space technology can innovate their business model. And for this, we have several partnerships in place, not only with national governments, but also with the institutions, European and international institutions, but also with city and let's say region. So in the air quality, there are several applications and opportunities that can be supported leveraging space data with no space technology. And I will provide you now in the following slide some example of the application that we have developed. So now moving to the next slide. In this activity, the algorithm, which is called actually AirCheck, calculate and forecast the air quality, aiming to produce a unique air quality index, which basically translates the set of pollutant concentration into a number which is easy to understand to allow the people to take, let's say, action. And this index is, of course, obtained by reaching the air quality model with the Earth observation measurement with data from in situ sensor. And for example, one example of the target market in this case for this algorithm was the real estate, providing for each property that is on sale or to rent an indication of the surrounding air quality status. Now moving now to the next slide. This is an example of another application where the company developed an air quality dashboard, a portal, which collect, analyze, but also visualize air quality data based again on Earth observation measurement, but also images, ground data, but also traffic information, weather forecast, to produce a forecast of the air quality at the street level. And these forecasts are then used in the decision-making process by the city and the government in order to assess which measures need to be taken in order to improve the air quality and also to inform the public. In the next slide, this is another example of an application in the healthcare sector. So as Jean said, in the asthma, for example, sector. So this application enables users to select route and timing of their outdoor movement sport to minimize the negative effect due to the exposure to the air pollution. So the service leverage again on Earth observation data, ground sensor, but also IoT, artificial intelligence algorithm to monitor the air pollution, to disseminate the information to the public. And here you will see some example of this application. So now moving to the next slide. So this is a service which addresses the air quality in the transport sector. The service is basically designed to help the city to manage the air quality by employing different strategy which consider how the vehicle emission disperse, but also consider under certain climatic condition. So the application compute the traffic flow across the road network, so do a model and the forecast, and do this in conjunction with the air quality model, and then compare and compare different scenarios. And these are provided to the traffic manager in the city council. And these are guidance, suggestion on how, let's say, to make changes in the traffic flow in order, let's say, not to pollute, for example, so much a certain area and so on. And here the system use, in addition to the Earth observation data and ground sensor, also the vehicle position, but also data on the traffic, like the speed, the density, and so on. Now going to the next slide. So another application that I would like to mention that we have developed is in the context of the green building, which is so they are building which are environmentally responsible by, let's say, more efficiently using energy, water resources, reducing waste and pollution. And here in particular, I would like to draw the attention to a service, which is service to monitor the outdoor air pollution for inside the ventilation purposes using space data and also 5G. So this application basically integrates the outdoor air quality information in the ventilation system of the building, so it can improve the air quality indoor, considerably by reducing the ventilation when the outside air quality is bad and the other way around. Now, in the next slide, I would like to mention briefly an upcoming initiative on monitoring and detection pollution in the air, water, and soil. So this is an initiative upcoming which address the fact that the pollutant, for example, entering the water stream pollute the soil, and then as the water evaporates, pollute the atmosphere. This paved the way to the so-called pollution cycle. So this is an initiative that we are now developing at the moment in cooperation with some European city, and is an invitation to tender that will be issued at the beginning of next year. So this initiative hopefully should lead to sustainable space-based services which can contribute to the monitoring, to the detection of the pollution in air, water, and soil in several vertical sectors, in particular the transport, the agriculture, the industry. So, and now moving to the next slide. Here in the next slide, you see an overview of some of the current funding opportunities that have been already issued. You see that there is a large variety of thematic areas. There are a lot of initiatives related to the smart city and the environmental services, and in particular, I would like to draw your attention to the call on the marine energy, to the call to the circular city, and to the initiative on connected rural community. And with this slide, I would like to conclude. Thank you for the opportunity. For those of you that want to enter in contact with us, you find my email here. Thank you.
Thank you very much, Roberta, for this. A lot of interesting also funding possibilities for doing some more research on the topic. We are now at the end of our presentation block. We're very good in our timing, I would say. So we have a little bit of time for some questions as well. And one question I have here, which I would like to ask you specifically, our representatives from the two cities. If you look at what you have in mind to improve air quality and also your air quality monitoring and prediction in your city, is there something that you will take home from this seminar where you can see potential that you could use that or that you get some inspiration for your own projects in the future? I would like to give this question first to Romain and then to Jean, please. Do you have something?
Yes, thank you
for us?
Thank you for the question. I would say one of the key takeaway is, in my mind, what presented Massimiliano Ferrante about the educational role upon the management of air quality monitoring. It is a thing that come to the project I've presented to you, and this is a key point for our policy in Paris. We have to change habits of a lot of bad habits that do air pollutions, like wood burning, traffic, and we think that by reaching the most of people and teaching them the roles they can have in this fight, and education is a great way to do it, because when you teach the kids, they will teach their parents, and so it is most part of what we try to do.
Okay. Yes, I find that also very interesting. I would also like to hear what Jean has to say on this, what she thinks she could take home.
Sure,
Do you have
of course. I think there's 2 points that pop out to me. One is the work going on in France, and we have been very much involved in following along with the participatory budgeting work in Paris and a variety of other ways to get people more engaged with the government and how to connect with it. And I think the idea of helping citizens have a choice and selection of like where to put the monitors as well, I think kind of comes out to me as an interesting aspect of it. We're doing that right now with a program around slow streets where we're moving towards more pedestrian friendly areas and decreasing the speed limit. And we're letting the communities themselves select if they want to be part of that community and part of that initiative. And the other thing, I always love listening to Roberta, and the other thing that's just brings that she brings to mind is this connection with businesses, right? So like the startups who are consuming that data and using that data to create apps and health enterprises and that kind of thing. We do a little bit of that, but I think she's just reinforced with me even more of that to be able to have more consumption of space data in practical ways.
Okay, thank you very much, Jen, for this. I think we can have one more question maybe. And I would like to address this question towards my colleagues, Massimiliano and Roberta. Based on what has been achieved so far, where do you think what do you think can be done to improve air quality modeling, specifically the prediction from your perspective? Maybe from one side from the measuring point of view and maybe also from the funding point of view. Massimiliano, can you reply to that?
Yeah, thank you, Robert, for the question. Actually, our activity is focused on the first part of the air quality modeling, that is the measuring of air parameters, and these measurements are for educational purpose. But from our point of view and from AQP project, the increasing number of local points of measurement, for instance, using Internet of Things sensors, merging local values with satellite values, increasing the quantity of the collected data, put together data come from a different system and organization, and in the end, using machine learning algorithms could be method that can improve the air quality modeling.
Yeah, I agree on that, if you have more measurement points. And Roberta, I think we have time for one more short answer or comment.
Yes, I would like actually to add exactly as you have said before that, let's say to improve the air quality model, basically, I would like to consider the 3 elements. From one side, you have the space data. So we have heard that increasing the resolution, increasing the accuracy, and maybe also keeping satellite with, let's say, sensors which are able with more extended capability to trace more of this poisonous gas. This would be certainly a plus. Then we have the value of the in situ air quality monitoring station, which are extremely important. But as we have heard, these are data which are coming from a fixed location, which are maybe not representative of a larger area. So increasing this network, maybe even optimizing the location of this is something important. Now, these 2 are the main input for the air quality model, which then simulate all the process of how these pollutants react and so on. And clearly, let's say this, it's very important, as Jean said, and we are working with our company to increase the accuracy, the reliability of this. Also important to add, to include more sophisticated machine learning, but also deep learning algorithms. So I see that it's the combination of these 3 factors which should lead to improve the air quality model. And this ultimately will make possible more innovative and more application in several sectors.
Thank you, Roberta. I think this brings us to the end of our little webinar on air quality and cities and smart cities. I would like to thank very much our guests for their contributions. This was really an interesting panel. I would also like to thank our viewers who have watched us here on the ESA Web TV channel, and follow us on Twitter at ESA or on our website, you will always find more updates on the air quality and on other space and Earth related topics, and also other space topics, of course. And I would like now to hand back to Donatella, and I thank you all very much again, and see you next time.
Thank you very much, Robert. I take the opportunity to thank you, to thank all the speakers for this very intense and very enriching session. I would like also to thank you all who have followed us, and the story is not finished. I give appointment to you next week on the 26th of November for our next episode. It will be dedicated to urban planning, and I wish you a very nice day.